Okay, so hi everybody. So this is going to be the review for the Unit 1 test for Algebra 2. If you happen to be watching this from another class, ignore some of the notation stuff. That's just what I use to keep track of everything. Okay, this is more than what's going to be on the test, but it's a really good review of everything. And if you notice, everything kind of comes in pairs of twos, so it kind of tells you like what's going to be the focus on the test. Okay, so the first question. Given the function g of x is equal to 2x squared plus 3x minus 2, find g of 5. That means just plug it in. So g of 5 is going to be equal to 2 times 5 squared plus 3 times 5 minus 2. So this is 2 times 25 plus 15 minus 2. This is equal to 50 plus 15 minus 2, which gives you 65 minus 2, which gives you 63. Okay, so g of 5 is equal to 63. Okay, oops, sorry, went off the page. Okay, next question. Given that is equal to 5 minus 3x squared, find f of negative 2. So you do have to be careful with the negatives plugging in here so you don't lose them. So f of negative 2 is equal to 5 minus 3 times negative 2 squared, which is 5 minus 3 times 4. Which is 5 minus 12, which gives you 7. Okay, so there we are. Oops, sorry, negative 7, not 7, negative 7. 5 minus 12 is negative 7. Okay, next one. For the graph below, find the domain of this. Okay, so we're really going to focus in on interval notation. Okay, so remember with interval notation, when you have the parentheses, it means it can't be equal to the bounds. Okay, can't actually is not equal to bounds. But when you have a bracket, it does equal at bounds. Okay? So the domain, if you recall, is a set of x's. So the x's down here of this graph are how much you're going to the right and how much you're going to the left. If you notice, you're here and you go to the right forever. And I know it's not going to the right very quickly, but it is continuing to go to the right. Same thing over here, it's going to the left forever. So the domain is all real numbers. Now the way that we write this, there's different ways, but the way we write this in interval notation is negative infinity to infinity. Okay, like that. You can't be equal to negative infinity or infinity, so that's what it is. Okay. Now the range is a set of y values. Okay, if you notice down here, and I know it's hard to see, but this is negative 2, so this y value is negative 1. So it's going to be at negative 1 and everything up above. It's going to go up forever. So it's going to go from negative 1 to infinity. It can equal to negative 1, so we're going to write this in as a bracket, and then parentheses because it can't be equal to infinity. Okay? Intervals where the function is decreasing. Okay? So decreasing means as it goes from left to right, it has to be going down. So if you look, follow the graph, as you go from left to right, it's going down, 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 and then it goes back up again. So in other words, from this point all the way until this point is where it is decreasing, and that means the x values. Okay, so these are the x values. So it's going all the way back forever, right? So this is going to be from negative infinity all the way until x is equal to negative 1. So negative 1 is where it's decreasing. Now, at negative 1, it's actually doing neither increasing nor decreasing. Okay, because it goes from decreasing to increasing. So at negative 1, it's actually doing neither. So I'm going to put a parentheses on this. Okay, and then the minimum value, so this refers to the y value. What's the smallest y value you can have here? Well, that's just negative 1. Okay, so that's the answer. Okay, next page. Okay, so same type of a question. Like I said, these all kind of come in pairs of 2, right? So the domain is a set of x values. If you notice, it's at negative 1, and it goes only until positive 1. It stops there because it's a point. So the domain here is from negative 1 to 1. Once again, you have the brackets because it can be equal to those things. Okay, so the domain is a set of x's. The range is a set of y's. So the y values go from 1, because that's the y value, down here to -4. So we want to put this in interval notation with the lower number first. So this is going to be -4, comma 1. Okay, it takes on all the values between -4 and +1. Okay, intervals where it's increasing. So it's increasing from there to there, which is -1 to -2/3. So this is going to be -1 to -2/3. Now, what is it doing at -1? Is it increasing or it's decreasing? It is technically increasing on that interval. So I'm going to include that, but it's not increasing at -2/3. Okay, once again, it's like it goes from increasing to decreasing there, so it's not equal to it at that spot. Okay, and then the maximum value, once again, the maximum value makes reference to the y value. You can clearly see on this graph that the maximum value occurs there. What is the y value there? It's 1, so the maximum value is 1. Okay, next question. Does the find represent a function? Okay, vertical line test or pencil test. Take your pencil, place it on there. Does it ever cross in more than one spot? If the answer is no, okay, so does it cross in more than one spot? If the answer is no, then yes, a function. If the answer is yes, then no, not a function. Okay, as you place it on here, as you can see, you go straight across. It never crosses in more than one spot, so no. So yes, this is a function. Okay, now this one's a pretty crazy graph, but if you zoom in and you take a look here, doesn't matter where I place my pen, it's never going to cross in more than one spot, okay? I could do it over here, and if I draw on a vertical line there, it's only going to cross in one spot. One spot, one spot, one spot. Doesn't matter where I place it, it's only one spot. So yes, this is a function. Okay, next page. Okay, so here you have this ellipse, and if you draw in a vertical line there, you see it crosses there and there. So no, this is not a function. Okay, the next one, does the following relation represent a function? Okay, so if an input value maps to more than one output value, then it is not a function. So for example, if you look at 2, 2 gets mapped to 2, but 2 also gets mapped to 4, right? 2 and 2, 2 and 4, and since it does that, no, it is not a function. Okay, it can only go to one input or one output. Okay, identify the parent function of g of x equal to the square root of x minus 1 plus 2. So hopefully you recognize that y is equal to the square root of x is the parent function. So normally when you graph this function, it looks like this. But then we have to determine what the translation is. Okay, so the plus 2 on the outside, let me do this. Okay, this is a vertical shift. Up 2. Okay, and then the minus 1, now remember, when it's inside with the x, when it's in there in the same grouping as the x, it does exactly the opposite of what you think it would do. So since it's minus, it's gonna be a horizontal shift. To the right 1 unit. Okay, once again, it does the exact opposite of what you think it would do here. Okay, so you're going to take this graph and you're going to move it up 2 units. Now, there's a graph here. You can decide, however, what you want this to be. I'm going to go ahead and see 1, 2. So I'm just going to move up 2 units, 1, 2, and then it's going to go to the right 1 unit. So there, so the graph will look like that. Okay, if you want to make it more accurate, go ahead and plot in some points to determine where that's going to be. Okay, next question. Okay, identify the parent function of y is equal to negative x plus 4 squared plus 1. The squared is the big indicator there. So y is equal to x squared is going to be the parent function, or f of x, or whatever you want to call it. Okay, and that graph would look like this. Okay, once again, I'm just jotting in there really lightly. Okay, the +1, that is a vertical shift up 1 unit. Okay, now once again, here's the +4, right? It is inside, it is in with the grouping with the x. So you're going to do the opposite of what you think. So this is going to be 4 to the left. Okay, so this is a horizontal shift 4 units to the left because it's opposite of what that is. So I'm going to go up 1 unit, and I'm going to go to the left 4 units. So this is going to be hard. Let me see. So 2, 1. So I'm going to mark this as 1 units. Oh, this is really bad. Okay, so I'm just going to mark them like this. Okay, and so on. So it gets moved 1 unit up and 4 to the left. So 1, 2, 3, 4. So that's where it normally would be, but you have to pay attention to that negative. That negative flips the whole entire thing. So the graph will look like this. Okay, the next one. Identify the parent function of this equation and graph the function. So hopefully you recognize that y is equal to the absolute value is the parent function, and that is going to look like this. Okay, and then here, this -5 is on the outside, so this is going to be a vertical shift, but it's going to shift it down 5 units. And then right here, this is going to be, so it's inside, it's once again, it's in that grouping with the x, so it's going to do exactly the opposite of what you think it's going to do. So it's going to move so it's going to be a horizontal shift and 8 units to the right because it's negative. So I'm going to go down 5. 1, 2, 3, 4, 5, and then 8 to the right. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to go like that. Okay, so that's what that graph is going to look like. Okay, the dotted line is the parent function. The translation of it gives you that. Okay, next one. The function g of x equal to x cubed has translated 2 units down and 4 units to the right. What is the new equation? Okay, so we have g of x is equal to 4 units to the right. So the horizontal shift, you remember, does the opposite of what you think it's going to do. And once again, up here, this is a horizontal shift, 8 units to the right. Horizontal shift, 4 units to the left. Okay, so since it's to the right, it's going to end up being -4. So I have x minus 4 like that, cubed, because it was cubed to begin with. And then 2 units down, so it'll just be a -2 on the outside. So that is your answer. Okay, so the function g of x equal to the absolute value of x gets translated 6 units up, 2 units to the left, and gets stretched vertically by a factor of 2. Okay, so the equation then becomes g of x is equal to 2 units to the left. So horizontal shift, you're going to do the opposite. So this would be x plus 2. 6 units up, so plus 6. And then get stretched vertically by a factor of 2, so you just place a 2 in front of that. Okay, and this is my answer. Okay, next one. I know there's a lot of questions here, guys, but I wanted to make sure you guys have a good review, and it's nice because you can go back and watch this video anytime you want. Okay, and or like fast forward through the pieces you don't need. Okay, the function g of x is equal to the absolute value of x, the square root of x, gets translated 3 units up. So that's going to be a +3 on the outside, and 2 units to the left. So the horizontal shift is opposite. So this is going to be a +2. So the equation becomes y is equal to the square root of x plus 2 plus 2. Okay. And you could have put something different there, g of x, f of x, whatever you wanted to. Okay, so find the average rate of change of the function. So this is actually really easy. So it's on the interval from -1 to 4. So the average rate of change is actually just the slope between the two lines. That's it. Okay, so go back to what is that slope form? M is equal to y2 minus y1 all over x2 minus x1. So in this case, I'm going to make this my x2, y2, and this is my x1, y1. So I have 9 minus 4 all over 4 minus a -1, so plus 1. So 5 over 5, which gives me 1. Okay, so average rate of change, that means just find the slope between the 2 points. Okay, now here's a little different because now they didn't give me what the graph was. They gave me the equation, they gave me the coordinates, or the interval, so now I'm supposed to find out what the average rate of change is. So all you do is you first figure out what f of 2 is, so plug it in. The absolute value of 2 times 2 minus 1 plus 3. Absolute 4 minus 1 plus 3. So this is equal to 3 minus 3. Oh, that gives me 0. So that means it goes to the point 2, 0. Let's try -2. So f of -2 is equal to the absolute value of 2 times -2 minus 1 plus 3, which is equal to -4 minus 1 plus 3, which is equal to -5 plus 3, the absolute value of -5, which is equal to 5 plus 3, which gives you 8. So this one goes to the point -2, 8. So there are my 2 points, so just find the slope between those two. So I have m is equal to y2 minus y1 all over x2 minus x1. So it doesn't matter which one you choose as your x1, y1, just don't mix them up. Okay, so if this is going to be your x1, y1, and this is your x2, y2, just make sure the 1 goes with the 1 and the 2 goes with the 2. So I have 8 minus 0, because it's y2 minus y1. y2 is 8, y1 is 0, all over -2 minus 2, which gives you 8 all over -4, which is equal to -2. Okay, so the average rate of change, or the slope, is equal to -2. So just find the slope between the 2 points. Okay, next one. Find the inverse of the function g of x equal to 5x plus 6. So remember, the step 1 is you just rewrite it with the y. Okay, step 2 is you switch the x's and the y's. Step 3, you solve for y. I'm going to go plus 6, plus 6. I have x plus 6 is equal to 5y. I'm just going to rewrite it up here only. So x plus 6 is equal to 5y. Then you get rid of the 5, so divide both sides by 5. So, and I'm going to switch them around because I don't like to have the y on the opposite side. So y is equal to x plus 6 all over 5. And remember, the last step is for the inverse, you have to put g -1 of x. If it's g, then the inverse is g -1. So g of -1 of x is equal to x plus 6 all over 5. You could also rewrite this as 1/5 x plus 6. Either one of those would be the same answer. Okay, next one, find the inverse of this function. So once again, we rewrite it. Y is equal to x squared minus 4. You flip the x's and the y's. You solve for y. So you add 4 to both sides. So you have x plus 4 is equal to y squared. Once again, go up here. I'm going to switch it around the other way, just in anticipation of the next step. Okay, now to get rid of the square root, or square, I need to square root both sides. But when you do that, you have to have the plus or minus. So you have y is equal to plus or minus the square root of x plus 4. Okay, and then the last step is substitute back in the inverse notation. So you have the inverse function of f is equal to plus or minus the square root of x plus 4. Okay, next question. Okay, draw the graph of the inverse function below. Okay, if you remember when I taught this, the key portion of this is knowing that the inverse function is the reflection across the line y is equal to x. So here is the line y is equal to x. Right there and right there. And then all I need to do is reflect this line across it. Okay, so the point that's on the line is going to stay there, right? If you reflect it on a mirror, it's going to be still in the mirror. So this point will go directly across over there. And then like this point will go directly across to over there. And then I can just draw my line. Okay, so if this is f of x, then this is the inverse of f of x. Okay, same question down here. You had to find, graph the inverse. So once again, I'm going to draw on the line y is equal to x. And then I just flip this across. So this point stays where it's at. This point gets flipped over here. That point gets flipped over there. And my graph will go like this. It probably more curves out like that though. Okay, so there it is. Okay, almost done. We're getting close. A few more pages left. Okay, so given the function f of x is equal to 1/2 x minus 3 and x squared minus 1, where this equation works when x is less than 0, this equation works when x is greater than or equal to 0, you want to find f of 3. So you take 3 and you plug it into the top equation or the bottom equation, depending on where it quantifies. So 3 is the value. X is equal to 3. Is 3 less than 0 or is 3 greater than or equal to 0? It is greater than or equal to 0, so I'm going to use that equation. So f of 3 is equal to 3 squared minus 1. So 9 minus 1 gives you 8. Okay, next one. Okay, so given the function, now we have 3 different values here. I want to find f of 2 minus f of negative 2. So let's do one at a time. So f of 2. So I'm less than negative 2? No, because it's equal to 2. I'm equal to negative 2? No. X is greater than negative 2? Good. 2 is greater than negative 2, so I'm going to use this equation. So that's equal to 5 times 2 minus 2. So 10 minus 2, which gives you 8. So f of 2 is equal to 8. Now let's do f of negative 2. Okay, so f of negative 2, if you go here, oh look, it's right there. That's f of negative 2, and it's just going to be equal to 4. So that's it. So f of 2 minus f of negative 2 is equal to 8 minus 4, which gives you 4. Okay, because f of 2 is 8, and f of negative 2 is 4. Okay, graph the function. Okay, so I haven't focused that much time on this, but I don't think it's too bad because you just have to graph both of these individually, okay? Now the cutoff point there is x is equal to negative 2. So if you go to negative 2, there's going to be like this invisible line. This is not part of the graph, but I'm just dotting it in. So you can see at this point in time, the graphs are going to change. So you have 2 equations. You have y is equal to 4, and that's when x is less than or equal to negative 2. And then you have the equation y is equal to 5x minus 2, and that's when x is greater than negative 2. Okay, so less than or equal to negative 2. So that's going to be back over here in this area. So it's simply equal to 4. So 1, 2, 3, 4. So the graph will just look like that. Okay, now it's less than or equal to. So less than or equal to means that at that spot, it's going to be a closed circle. Okay, now as I go to the right here then, this equation is going to work. And this is in slope-intercept form. So that means the y-intercept is negative 2. Oops, yeah. And then the slope is going to be 5. So from that point, I go up 1, 2, 3, 4, 5, and over 1. So the graph looks like this. Okay, but this graph is valid all the way back until this line. So you have to keep going down until it hits there. Maybe it should be a little bit lower. Okay, and this only works when x is greater than -2, which means you need to have an open circle right there. Okay, closed circle there, open circle there. Okay, next question. Okay, find the missing terms of the arithmetic sequence. Okay, so it's arithmetic, which means you're adding on the common difference. So how many times you add on the common difference? You add it on once, twice, 3 times. So if you took 2 plus 3d, well, that should be equal to 11, right? 2, and you add on the difference 1, 2, 3 times, and it should be equal to 11. So subtract 2 from both sides. 3d is equal to 9. Divide by 3. D is equal to 3. So my common difference is 3. I'm adding on 3 every single time. So if the first term is 2, then A2 is 2 plus 3, or 5. Excuse me. And then A3 is going to be 5 plus 3, which gives you 8. Then if you add 3 to this again, you should get 11, and 8 plus 3 does give you 11. Okay? So these are my answers for A2 and A3. Okay, same thing. You're at -15, you're going to add the common difference once, twice, 3, 4 times. So -15 plus 4d is equal to 1. Add 15 to both sides. 4d is equal to 16. Divide both sides by 4. D turns out to be equal to 4. Okay, so we're adding on 4 every single time. So the next one, A2, is going to be -15 plus 4, which gives you -11. A3 is -11 plus 4, which gives you -7. And A4 is equal to -7 plus 4, which gives you -3. And once again, if you added 4 to this, you should get back to 1, and -3 plus 4 does give you 1. Okay, so these are my answers. Okay, I know this is a long review. I just want to make sure it's very thorough, and you guys can take your time going through this. Okay, so now it's geometric. So geometric, you're no longer adding on the common difference, you're multiplying by the common ratio. So what do? You take 8, multiply by r once, twice, 3 times until it's 8. So 8r cubed is equal to 1. Divide both sides by 8. R cubed is equal to 1/8. And then I have to take the cube root of both sides. So you have r is equal to, well, the cube root of 1 is 1. The cube root of 8, what number times itself again is equal to 8? And that number is 2. So the common ratio is 2. So to get from 8 to the next number, you just have to multiply by 1/2. So A2 is equal to 8 times 1/2, which gives you 4. And then A3 is equal to, so if that's 4, I have to multiply that by 1/2 to get 2. And then if I did it again and multiplied by this 1 by 1/2, I should get 1. Well, 2 times 1/2 does give you 1. Okay, so those are the missing ones. Okay, find the missing terms of the geometric sequence 1 through 64. So once again, I'm going to multiply by r once, twice, 3 times to be equal to 64. So 1 times r cubed is equal to 64. So r cubed is equal to 64. Take the cube root. So r turns out to be equal to 4, because 4 times 4 times 4 equals 64. So that's what the common ratio is. So now I go up here. So A2 is equal to 1 times 4, which gives me 4. And then A3 is equal to 4 times 4, which gives me 16. Okay, so those are the next items. Okay. Example 28. Long one, huh? In arithmetic sequence, the second term is A5. So If you remember what I do is I go like this. So this is A1, A2, A3, A4, and I just basically continue that. Okay, so the second term is 5. This is arithmetic. And the third term is 11. So you know the common difference can be found by taking any term in that sequence and subtracting it from the prior one, which gives me 6. And if you just look at this, 5 plus what number is 11? Well, it's 6. Okay, so the common difference is 6. So in order to complete this, I need to just add on or subtract 6 from everything. Now, it's asking for the 20th term. And the equation for the 20th term is a of n is equal to a of 1 plus n minus 1 times d. So I want to find a of 20. Well, that's equal to a of 1. A of 1 is, oh wait, I don't know what it is. Now I know going forward, you need to add on 6 every single time. So if I was to go backwards, I would subtract 6. So 5 minus 6 gives me negative 1. So this is negative 1 plus 20 minus 1 times the common difference, which is 6. So negative 1 plus, so remember what I do is I actually use the distributive property here. So I take 20 times 6, which gives me 120, and then minus 6. So this is negative 1 plus 114, which gives you 113. Okay, number 29. Now notice I didn't tell you what type of a sequence this is. You need to determine what that is. Is it going up and down by the same amount, like adding or subtracting, or is it by multiplying? Okay, and hopefully you see, I realize this is a mistake. So this should be 25. Sorry about that. That should be 25. Okay, so are you adding or subtracting to get from one term to the next? So if you notice, if you multiply this or divide this by 5, you get to this. You divide it by 5, you get that. Divide it by 5, you get that. So this is going to be geometric because you're multiplying by the same thing. Remember how you figure out what it is. You take any term in the sequence and you divide it by the prior one. So r is equal to 1/5. So the explicit formula then is a of n is equal to a1 times r to the n minus 1 power. So this is equal to a1 is 25, times r, which is 1/5, raised to the n minus 1 power. Okay, and that's what the equation is. I should have the a of n in there as well. Okay, once again, find the explicit formula. Now, I didn't tell you if this is arithmetic or geometric. So is it adding up by the same thing each time, or is it multiplying? If you notice, you go plus 3, plus 3, plus 3. So the common difference there is 3, so this is arithmetic. The formula for an arithmetic is a of n is equal to a of 1 plus n minus 1 times d. A of n is equal to a of 1, which is 2, plus n minus 1 times the common difference, which is 3, and that is what my answer is. Okay, this next one's a little bit different than how we did it in class. Well, actually, no, this is the same, but the other ones are a little bit different. So remember what you do is you start off by plugging in 1. So this is 3 times 1 minus 6, which gives you, and then plus, so that's what happens, you plug in 1, and then you have to plug in 2, so 3 times 2 minus 6, plus, then you plug in 3, plus, then you plug in 4, and then you stop. Okay, and the reason you stop, because 4 is where you stop at, and I just plugged in 4. Okay, so this is negative 3 plus 0 plus 3 plus 6. So negative 3 and 3 cancel, so the answer turns out to be equal to 6. Okay, now, before we move on, I want to pay attention to something. Notice these terms. You have negative 3, you have 0, you have 3, and you have 6. If you notice, you're adding 3 plus 3 plus 3 again. This is arithmetic. And the common difference there is 3. Now, if you look at this equation closely, where does the 3 pop in? The 3 pops in right there. That is what the common difference is equal to. Okay, so just by looking at that equation, you should be able to determine what the common difference is. Okay, 4 more questions. Okay, so here, what I just got done saying is if it's in this form, the common difference here is equal to 4. Okay, pretty simple. Okay, so the sum of the first, this would be 30 terms, is equal to, so the formula is n all over 2 times 2 times a1 plus n minus 1 times d. So the sum of the first 30 terms is equal to 30 all over 2 times 2 times a1. Now, how in the world am I going to figure out a1 is? A1 is what I get when I plug 1 into this equation, or when I plug whatever this number is into this equation. So A1 is equal to 4 times 1 plus 2, which is equal to 6. So times 6 plus 30 minus 1 times the common difference, which is 4. And then I just have to work it out. Okay? So once again, this is 15. This is going to be 12 plus. Now, remember what I do? I take 120 and I subtract 4 to get 116, which is equal to 15 times 128. And I don't know what that is off the top of my head. Although it'd be pretty easy. It's 1280 plus 64, which gives you 4, 4, 3, 1, 1, 3, 4, 4. That's what the answer is. Sometimes I think I can do arithmetic in my head, and then I can't. I make all sorts of mistakes. Just a minute, just checking to see what the answer is. No. Oh my God. This wasn't even close, not even like remotely close. Yeah, because this should be 640. That's what it is. I'm sorry. So the answer turns out to be 1920. See, I told you I can't do it in my head. Okay, next one. Okay, once again, it's in this form, so this is arithmetic with a common difference equal to 2. So I have a of 40 is equal to 40 all over 2 times 2 times a1. So once again, remember a1 is what you get when you plug 1 into this equation. So plug 1 in, you get 2 minus 3, which gives 2 minus 5, which gives you negative 3, plus 40 minus 1 times the common difference, which is 2. So this is equal to 20 times negative 6 plus 80 minus 2, 78, which is 20 times 72, which is equal to 1440, I believe. Yep, 1,440. Okay, next. Okay, so now you notice that this one's different. Up here, when we did this one, you had 2 times the variable. Now you have 2 raised to that power. Okay, when it's in this form, it is geometric with r equal to 2. This number right there, that is going to be the common ratio. Okay, so the sum of a finite geometric sequence is s of 6 is equal to, remember it's a1 times 1 minus r to the power of n all over 1 minus r. Okay, a1, once again, you get by plugging 1 into this equation. So you have 2 times 2 to the first, which just gives you 4. So 4 times 1 minus the common ratio of 2 raised to the 6th power over 1 minus 2. So this is 4 times 1 minus 64, 2 to the 6th power of 64, over negative 1, which is equal to 4 times 63, 252? No, what am I doing? Yeah, that's definitely the wrong answer that I have on the solutions. Okay, so 4 times 60 is 240. 4 times 3 gives you 12, so 252. Yeah, that one's way wrong. On my solutions, that one's right. That's right. Okay, last one. Okay, so once again, you notice you have a number raised to the power, so this is geometric with r equal to 1/2. So the sum of the first 6 terms is equal to, wait a minute, why did I say 6? It only goes up to 5. Be careful here. Your first term you get is when you plug in 0. You see what I mean? It's tricky. So the first term is you get when you plug in 0, and then 1, then 2, then 3, then 4, then 5. There's 6 terms here. Okay, and then times A1 times 1 minus the common ratio, which I know is 1/2, raised to the power of n over 1 minus r. So this is equal to, okay, so A1 is what you get when you plug in that value. So if you plug in 0, you have 4 times 1/2 to the power of 0, which just gives you 4, because anything to the power of 0 is 1. 4 times 1 gives you 4. So this is 4 times 1 minus 1/2 to the power of 6 over 1 minus 1/2. So this is equal to 4 times 1 minus 1 over 64. 1 raised to the 6th power is 1. 2 raised to the 6th power is 64. All over 1 minus 1/2 gives you 1/2. Which is equal to 4. I know I'm going to have to add these two together, subtract these two together. So I'm going to write this as 64 over 64. Right? 64 over 64 is just 1. So then 64 minus 1 gives you 63 over 64 all over 1/2. Which is equal to 4 times 63 over 64 times 2 over 1. So that cancels to 16. That will cancel to an 8. So I'm left with 63 all over 8. Okay, that was a beast. 35 questions. That took a long time. I will definitely go over these in class, or if any of the rest of you guys are watching this from different classes, just make sure to ask your teachers about this. Okay, take care, everyone, and I'll see you later. Bye.